In this video, we'll see how to draw deformed shapes of beams. We'll draw the deformed shape starting from a moment diagram, we'll see the steps, and we'll do an example. First, let's go over the procedure. Let's be clear from the start. Drawing deformed shapes is a trial and error process. You'll make mistakes, you'll evaluate your solution, you'll fix your mistakes, and you'll repeat that process several times. There are 5 steps. Step 1. Evaluate your boundary conditions and draw points and slopes corresponding to all the displacement or rotation boundary conditions. Step 2. Identify the curvature for each segment of beam according to the curvature of the moment diagram. Step 3. Sketch a smooth curve that connects all of this information, that connects the boundary conditions with curves of the correct curvature. Step 4. Check your curve. When you're first learning, you'll make plenty of mistakes. So check the curve. Make sure that it respects boundary conditions, curvature, and appropriate continuity. Step 5. If any of the conditions aren't met, refine your curve and check again. You may need to go through this procedure 2, 3, 4, 5 times. This is a qualitative process. There's no numerical answer. So it's hard to actually evaluate whether you got the right answer. The one tool that you have is the checklist in step 4. If you satisfy all of the points in step 4, you'll have a correct answer. Now let's look at the example. This is a very simple example to start out with. A simply supported beam with the uniform load. The moment diagram is given there. And we know how this deforms. This beam is going to sag in the middle and it's going to be supported at the two ends. So I'd like to start with an example where we pretty much know the answer to start with. You can think of this as propping up a 2x4 between 2 bricks and laying down on it. So let's start going through this step by step. Step 1. Draw all the points and slopes corresponding to the boundary conditions. We have displacement boundary conditions at the left and right, so I'll sketch in 2 points corresponding to those boundary conditions. I know that my curve must go through those 2 points. Step 2. Identify the curvature of all the segments according to the moment diagram. Well, there's only one segment of the moment diagram, and over that whole segment the curvature is concave up. Step 3. Sketch a smooth trial shape. This is the hardest part when you're learning, and this is where people make the most mistakes. Let's just sketch something in. Say I sketched this curve. It starts at 0 at the left end, and it's concave up. We have a trial curve. Now let's move on to step 4. Let's check the curve. Let's check the boundary conditions. It meets the boundary condition at the left, but not the right. So we failed that condition. We'll keep checking the rest of the conditions to know if there's anything else wrong with the trial shape. The curvature implied by the moment diagram is concave up, and the beam is indeed concave up over that whole segment, so this condition is satisfied. And there's no point where we need to worry about continuity. So this was not correct. We will now refine the curve. So I've shown the old trial curve in the dashed line. We'll realize that we need to shift this down to satisfy the other boundary condition. And we'll go through and check again. So we'll drop out the old curve. We only have the new deformed shape. Let's check all the different conditions. Boundary conditions, yep, it goes through both of the supports. That condition is met. Curvature, concave up everywhere. That condition was already met. Continuity, not applicable in this case. So at this point, we've gone through the checklist, we know that it satisfies all the conditions, and we're satisfied with our final answer.